Okay, recording. Hello everyone, welcome to this video. So for this video, we're going to talk about how to do one-way ANOVA in Excel. So first, use one-way ANOVA to test whether the means of at least three groups are different. Remember in our previous discussion about t-test, we're going to use t-test if we're going to test the significant difference between two means. Okay, but when talking about three or more, we're going to use ANOVA. ANOVA stands for Analysis of Variance, or ANOVA, Analysis of Variance. Okay, Excel refers to this test as single factor ANOVA. This post is an excellent introduction to performing and interpreting a one-way ANOVA test, even if Excel isn't the primary statistical software package. So first thing for this video, I'm just going to discuss to you about this PDF, and I'm going to demonstrate the ANOVA using Microsoft Excel on my next video, okay? So for now, let's just talk about this one. If you did finish reading this PDF, good. And if you haven't, just keep on watching, okay? So in my previous post, we look into Excel and performing t-tests, which compare two means at most, okay? One way ANOVA is a hypothesis test that allows you to compare more group means. Like all hypothesis tests, one way ANOVA uses sample data to make inferences about the properties of an entire population. It will also have like null hypothesis, alternative hypothesis, like that, okay? So in this post, we're going to provide instruction on using Excel to perform single factor ANOVA. When talking about ANOVA, Mangood is it has a single factor ANOVA, one-way ANOVA, and then there's a two-way ANOVA, or we're going to consider two factors already. There's also two-way ANOVA with interaction, and other thing is without interaction. And there's also two-way ANOVA with replication. So there's a lot of cases when talking about ANOVA. And so importantly, I also include links to many additional resources, and supplemental content presents clear explanation to relevant one-way ANOVA F-test concepts that you won't find in Excel documents. So while this post focuses on using Excel to run one-way ANOVA interpretation result, I've written a companion post. So in this PDF, you're going to see an example of uh, running the ANOVA in Microsoft Excel, and also an example of the result and its interpretation. So first thing to do, we need to have the data analysis. This one. This is an add-in, so you're just going to go to settings. I already recorded a video tutorial for that, how to add these plugins or add-ins, data analysis. Okay, so one way ANOVA in Excel, one way analysis of variance requires a categorical factor for independent variable and continuous variable for dependent variable. So when talking about ANOVA, we have two types of variable. First is the independent variable, and that should be categorical. And then the other one is the continuous variable, which is the dependent variable. The values of categorical factor divide the continuous data into groups. The test determines whether the mean differences between these groups are statistically significant. For example, a fertilizer type is your categorical variable. You can determine whether the differences between plant growth means for at least three fertilizers are statistically significant. So, for example, there's a three type of fertilizers, and then we're going to see if there's a significant difference among those three types of fertilizers. While the means can differ between between your groups, their variability should be roughly equal to obtain valid results. Okay, so this is how you're going to perform. So right after the data menu, click on data analysis and then click on ANOVA single factor. So for our Microsoft Excel, we have three options for ANOVA: ANOVA single factor, ANOVA two factor with replication, and the ANOVA two factor without replication. And then we have correlation, covariance, descriptive statistics, exponential, smoothing, F-test, two sample for variances, and then for year analysis. then histogram. So those are the tests when talking about data analysis. But for this discussion, we're just going to focus on ANOVA, okay? So as usual, you're going to have a null and alternative hypothesis. All group means are equal, and then not all group means are equal. And then if the p-value is less than your significant level, say for example 0.05, then we reject the null hypothesis. Your sample data support the hypothesis that means of at least one population is different from the other population means. Again, hypothesis test use sample data to draw conclusions about the population. To learn more about the Nova test, include a complex form. So those are some links. There's some links. Okay, so here are the steps instruction for running one-way factor ANOVA. So I'm going to demonstrate these steps later on my example using the Microsoft Excel. And here are some steps, specific steps. And then here are the dialog menu that we're going to pop up. So basically the concept is just the same in our previous discussion of t-tests. And here are the sample result when doing an ANOVA test. So as usual, the first table will be the descriptive statistics showing the sum, average, and then the variance. And then the second table will be what we call Anova Table, in which you can see the sum of squares, degrees of freedom, mean squares, and then the f value. Actually, these values are just going to use to obtain the f, which is this f value is needed to obtain the p value. Okay, this f critical was obtained using the level of significance. Okay. So the summary table indicates that the mean strength range from low of 83794 for suppliers for to high suppliers. So what it said here is the mean. So you can see that in the first table in here. Okay? And our sample means are different. However, we need to determine whether our data supports the notion of population means are not equal. The differences we see in our sample might be result of random sampling error. So in our ANOVA table, the p-value is this one, the p-value 0.03, 0.031054. Because this value is less than our significance level of 0.05, we reject the null hypothesis. Our sample data provides strong enough evidence to conclude that four population means are not equal. So for more information about our other statistics in the output, check. Okay, so there are just some examples. So what are the Excel one factor ANOVA does not include? So using the same data sets, Excel one-way ANOVA results match does those from my dedicated statistics software such as the SPSS, or there's other software as well, is you can, as you can see in my, so there is no this one post hoc test. Post hoc test is used to determine among those means of which of those means is the one the different ay katong yung kanang minglahi jud siya bitaw asa ato nila nga mga means ang lahi jud among the others. Muna siya gamiton use post hoc to determine that one. When using ANOVA statistically significant results, so ang ANOVA man good is i-identify niya kung na ba significant difference or wala. Yes or no ra na siya, guys. But we can't determine kung asa ato among the three ang minglahi, significantly lahi. Okay? Among the others. So, since di man siya makuha sa ANOVA, we're going to proceed to the post hoc test. But we can only proceed to post hoc test if na-prove na to nga naa significant difference among those means using the ANOVA. So, sumpay ni siya nga test, guys, ang ANOVA and then the post hoc. When talking about post hoc pod, there are a lot of different tests for post hoc depende sa inyong sample. There's the Cheffe, there's Chukay, which is kana siya nga test, wala na siya sa Excel. But when talking about SPSS, na siya complete siya tanan. I'm going to demonstrate that on my future uploads as well, on my future video as well. But for this video, let's just focus on this one. Okay? So, always remember, ang ANOVA, single factor, na ana siya ay duha ka variable. Ang isa is independent, which is should be categorical or na siya categories. And then the isa is dependent, which is naka-ratio na siya or katong numbers jud. Okay? Two variable. And then another one to remember is gamito ng ANOVA when determining if there is a significant difference for three or more means. Okay? Three or more. Kay kung two na siya, balik mo sa t-test. Okay? But kung talking about three or more na, use ANOVA, single factor. Okay, so that's all for this video, and I'm going to proceed to my next video about the two-way ANOVA, or we're going to consider two-factor ANOVA. And then for my next video, I'm going to have the examples. How na lang ako ang example guys sa Excel, like one way, two way, and then katong with replication. Para isang run na lang ba? Para ma-familiarize po mo diretso na siya. Straight. Okay? So that's all for this video, and have a great day.